Today we're going to be going back and revisiting the synthesis of mercury thiocyanate, also known as the Pharaoh Serpent. It's actually one of the first videos that I made, and it's my most popular video by far, but I feel if I revisit it, I can do a better job this time. I don't know why, but in my earlier videos, I kind of sound like I hate everything that I'm doing, so in this one, I'm going to try to at least sound a little bit excited or enthusiastic. I thought it'd be a little bit lame, if I redid the other video just shot for shot. So in this one, I want to do things differently, so I scaled everything up by 10 times. This video is really going to be just the preparation, so I'm going to be reacting mercury with nitric acid to form mercury nitrate, and then reacting it with potassium thiocyanate to form my mercury thiocyanate. Once the weather is nicer out, I'm going to try to make a good demonstration video, and I'm going to try to do some creative stuff because, I have over 300 grams of the mercury thiocyanate now. These are the chemicals that I use for this reaction, and from left to right, we have nitric acid, mercury, and potassium thiocyanate. I did this on a 1 molar scale, and to do this, I used about 180 milliliters of 68% nitric acid, 200 grams of mercury, and 200 grams of potassium thiocyanate. The nitric acid was made in a previous video, the mercury was collected from 1 billion old thermometers, and I bought the potassium thiocyanate from eBay. I started off by adding the nitric acid to a flask. Once it was added, I set up the rest of the apparatus, and you can see what it looks like here. The first step is to react nitric acid with mercury, and this produces a lot of nitrogen dioxide gas, and this apparatus is set up to prevent it from leaking and going everywhere in the lab environment. As the nitrogen dioxide is produced, it should be forced out into the inverted funnel trap you see on the right. The white liquid you see in the trap is just a sodium hydroxide solution, and this should really easily neutralize any nitrogen dioxide gas. The next thing that I do is weigh out about 200 grams of mercury. To do this, I use a glass syringe, and I'm going to be weighing out the mercury in the round bottom flask you see on the left. Once I've weighed out the 200 grams of mercury, I stop with the round bottom flask, and I wash the glass syringe a few times with water. Just pulling the water into the syringe and then squirting it back into the bottle serves to dislodge any mercury that might be stuck inside. Once the syringe is cleaned, we can recap the bottle and put the mercury back into storage. So before we start, this is what our setup looks like. We have our mercury on the left, our nitric acid in the middle, and our sodium hydroxide trap on the right. Below the hot plate, I put a plastic container just in case any spills occurred. When we're ready to start, I take out the glass adapter and we can begin pouring in a little bit of the mercury. As the mercury is poured in, we can see that it immediately starts reacting with the nitric acid. The reaction here is pretty simple, and what's happening is the mercury is reacting with the nitric acid to form mercury 2 nitrate. The mercury 2 nitrate is our desired product, but to some degree we are going to be producing mercury 1 nitrate. There's a very easy way to deal with this, and I'll show what we do in a bit. When we look at the reaction, it actually looks pretty cool, and we can see little drops of mercury bouncing up and down. At this point though, the reaction still isn't very vigorous because the solution is relatively cold. As the reaction continues though, it's going to produce heat, and as the solution heats up, the reaction rate is going to increase. Once the initial amount of mercury is gone, we can start to add more, but you have to be really careful. The solution now is much hotter than before, which means that the mercury that we add is going to react much more vigorously. With that warning in place, I'm going to go ahead and show you exactly what happens if you ignore that warning. I got a little bit too bold and I thought that the reaction wasn't going to be super vigorous, so I poured in way too much mercury. You can see what happens after I did this, and it was almost a disaster. The reaction just started to take off and the foaming became extremely problematic. It started producing a crazy amount of nitrogen dioxide gas, and the reaction almost foamed out of the Erlenmeyer flask. This is the exact reason why I included a container underneath the Erlenmeyer flask because, things like this can happen, even if you think you know what you're doing. For several seconds though, I was honestly really scared because you really don't want mercury nitrate all over your lab space. For me, I was lucky that the foaming died down before it overflowed, but it was nonetheless a pretty scary experience. The amount of nitrogen dioxide being produced is also way more than the trap can handle, so you can see that it's just basically being pumped into the air. After a while, though, the reaction rate starts to slow as the mercury is used up. Eventually, we'll have a very clear solution with just a little bit of bubbling occurring. As the very last bit of mercury is reacting, we can now turn on the hot plate. The next thing that we need to do is boil our mercury nitrate solution. This step serves to do two things. It A, converts mercury 1 nitrate to mercury 2 nitrate, and it also gets rid of nitrogen dioxide gas that's still dissolved in the solution. As we boil the solution, the solubility of nitrogen dioxide decreases, and it's going to be expelled. As this happens, the color of the solution should decrease very slowly until it eventually becomes colorless. This actually took quite a long time, and I think I boiled the solution for something like an hour. Eventually, it was very nearly colorless, and there was just a little bit of nitrogen dioxide gas that was still coming off. At this point, I figured I was pretty much done with the boiling, so I turned off the hot plate and added a little bit of distilled water. I kind of arbitrarily decided to add more water, and in total, I added about 200 milliliters. The mercury nitrate solution is extremely concentrated and it has a high density, so when the distilled water is added, it floats on top. So, just to get everything mixed, I took the Erlenmeyer flask off the stand and swirled it around. While I was waiting for the mercury nitrate solution to cool, I went ahead and started preparing the potassium thiocyanate solution. To do this, I dissolved 200 grams of potassium thiocyanate in about 500 milliliters of water. The amount of water that you use doesn't really have to be exact, you just want to have a really concentrated solution. 500 milliliters is way more water than we need, but the reason why we use this much is because the dissolution of potassium thiocyanate is endothermic. To dissolve, it absorbs heat from its surroundings, which in this case is water, so the water cools down. This means that the more that we dissolve, the colder the solution gets and the lower the solubility is. We could remedy this by simply putting it in the microwave or heating it up on a hot plate, but honestly, I was a little bit too lazy and it's really not necessary. It turns out that the mercury nitrate solution was still too concentrated, so I decided to dilute it to a volume of about 1200 milliliters. I just continuously washed the Erlenmeyer flask with distilled water and added it to the larger Erlenmeyer flask until I got to the volume I needed. Once it had been diluted enough, I just gave it a good swirl to mix everything around, and we're good to go for the next step. This next step is pretty simple, and all we need to do is add the potassium thiocyanate to our mercury nitrate solution. When this happens, there's an immediate reaction and mercury thiocyanate precipitates out. The most important part in this step is to go slowly, because if it's added too quickly, some side reactions can occur. You'll see here that I added a bit too much too quickly at the end, and a little bit of yellow appears. Luckily, I was able to get rid of this by just swirling it around a little bit, but you really don't want this tainting your reaction. After everything was added, I just washed the beaker a few times. After all the washings have been done, just let the Erlenmeyer flask sit, and the mercury thiocyanate should settle to the bottom. We're eventually left with a large water layer, and this is poured off into a mercury waste container. It's really important for obvious reasons not to pour this down the drain, because you'd be contaminating the sewer system with mercury. I really didn't want to have to filter a mercury salt, so I thought I'd get away with it by simply pouring it into a dish and letting the water evaporate. I washed the Erlenmeyer flask a few times just to get out as much of the salt as possible, and I also added this to the dish. The salt looked like it didn't have that much water in it, and I really didn't think it would take that long to evaporate, but I was really wrong, and this method doesn't work at all. So after realizing that this method was a total failure, I ended up having to vacuum filter it anyway. To do this, I just used a small beaker to scoop out the mercury thiocyanate and pour it into my Buchner funnel. This turned out to be the way better method, and I really regret even trying to evaporate it at all. All of the water that's filtered through is going to be contaminated with mercury, and this too has to go to a mercury waste container. Here you can see how much water was filtered through, and this is why it would take forever to try to evaporate it. Anyway, after everything was filtered through, I kept the vacuum on to try to dry it up as much as possible. Then using a spatula, I scraped it out onto a piece of paper. It took a few minutes, but eventually pretty much all of the mercury thiocyanate was scraped out of the Buchner funnel. Once it had all been removed, I just used the spatula to break up the large pieces, and then I tried to spread it out to let it air dry. While it was air drying, I moved on to doing some cleaning. Mercury thiocyanate is not soluble in water, so we need to clean it with hydrochloric acid. The hydrochloric acid will react with it to form mercury chloride, which is soluble in water. Just using hydrochloric acid in a squirt bottle, I cleaned the dish, the Buchner funnel, and the beaker that I used. Just after a few minutes, everything was relatively clean, but it's important to note that we've just solubilized the mercury salts. Soluble mercury salts are much more dangerous than the insoluble ones, so we have to be really careful and add everything to the proper mercury waste container. Each piece you see here was washed with a copious amount of water, and each washing was also added to the mercury waste. After a few days of letting it air dry, I was satisfied and I was ready to store it. To do this, I just lifted up the paper and poured all of the mercury thiocyanate into a glass container I got from IKEA. The final yield of the mercury thiocyanate was about 328 grams, which is actually higher than theoretical, so it means that it's probably still pretty wet. This is okay though, and it's really not going to affect the demonstration. In this video, I'm not going to show the demonstration because basically I haven't filmed it yet. The demonstration is going to come in a second video because I want to do this outside, but right now it's not warm enough. So for now, there's no demonstration, but that video should be released in at most 2 weeks or a month. I actually haven't done this yet, but I would like to give a big thanks to all of my Patreon supporters. You guys are extremely important to me, and you're one of the major reasons why my videos are even possible to make. I've changed the reward tiers a little bit, and I've made it so that if you spend $5 or more, I will include your name as a personal thanks at the end of each video. I'm going to try to read out the names, but don't kill me if I mispronounce any of them. So a big special thanks goes out to LVE, Eric Steinberg, Jan Beck, Victor Gonzalez, and John Leibel. On top of you guys, I actually have a lot of other $5 plus supporters, but I didn't include them because I'm not sure if they want their name included at the end of the video. I've sent a message to each of you on Patreon just asking if you do want your name to appear, because after all, you did not opt to be in any of the reward tiers.